Okay, another session with graph. Okay, another session with graph. Okay, anyway, another session again with graph. Okay, really, you are hearing that graph. It's a new graph, displacement time graph. Okay, in this almost it is same as distance time graph, but here what? In distance time graph, the slope of or the value of the slope gives us what? The value of the slopes gives us speed. Okay, but in the case of physics, speed is not an important thing. Okay, because distance will vary each and every time, but for purposeful calculation, what we are taking? We are taking velocity as the main thing. Anybody remembers the equation for velocity? Okay, displacement divided by time. Fine. So this is a vector quantity. Velocity is a vector quantity. You already know that. What is the unit? SI unit of velocity? Okay, meter per second. Good. SI unit of speed, also meter per second. Here also three types of displacement time graphs are there. Okay. First one, any difference than the distance times time graph? Nah, nothing. Understood? Sorry, one more time. Here, the slope gives velocity. That's the difference between these two graphs. Okay, displacement time graph and distance time graph. The slope of distance time graph gives speed, and the slope of velocity time graph gives, displacement time graph gives what? Velocity. Okay, let's start. So here, what all things we have? We have velocity, we have time. The first case is what? When the body is at rest, there is nothing. If the body is at rest, displacement and distance has nothing to do. They won't change. Okay, only the time will change and it will give the same graph like distance time graph. I think that is easy, and there won't be any slope. The slope will be 0. So can you find any velocity? No, only time is there. Let's see next. Body is moving with uniform speed. So why in this case two diagrams, two graphs are drawn, two lines are drawn? Because it has direction also. Velocity is direction dependent. Am I right or not? Distance means 10 meters means 10 meters in any direction. But in the case of velocity, we need to tell the direction. Displacement is measured in length and also in direction. So this is what the first one is: velocity of A and velocity of B. In this case, which body has more velocity? Which body has more velocity? Here it is said that the angle Q1 is greater than angle Q2. Q1 is almost this entire thing, this much, full it will come. Q2 is only this much, almost like a 38 degrees. So, whenever the angle which that line makes with the x-axis, it is bigger, we can say the velocity is higher. Understand? So, here the upside line has more velocity, the below line has less velocity. So, we can say that which body, A or B, is moving faster? A is moving faster. Am I right or not? B is moving slower than A. Okay? So, next one is body moving with variable non-uniform velocity. Same. See, there is no difference in this graph. Okay? Here only we are taking two cases. The same case we can take in that distance speed graph also. No, distance time graph also. The same thing. Understood? Understand? The same thing we can use. If the speed is decreasing means another point we will come. Understood? Here is also same, because the graph for distance time and distance displacement time is almost same. There is no difference. You already know that the value also is same. Am I right or not? Distance travel divided by time will give speed, and displacement divided by time will give velocity. Both units are same, and some of the cases the value is also same. This is the important part. Okay, velocity time graph is important part. It has three cases. See, 1, 2 and 3. And this is a bit twisty also. So this we will try to understand very carefully. Okay. So let's see what is velocity time graph. X-axis, which value will come? Of course, time. Y-axis, which value will come? Velocity. And with this, what we are getting? Some equation is there, velocity and time. Rate of speed, rate of change of velocity is what? Of course, it is given here. Acceleration. Understood? Acceleration. So now we are getting acceleration as the answer. If we are plotting velocity with time, we will get acceleration. Let's see. For a body moving in straight line without changing its direction, velocity of the body becomes equal to its speed. If a body is moving in straight line, at that case, distance and displacement are same. Am I right or not? I told in some examples. For example, if we consider railway lines, some of the railway lines for a particular distance, it is straight line. So there the distance and displacement will be same. Or if we are going through a straight highway, 10 kilometers straight highway, we are going straight, we are not changing our direction, straight. In that case also, displacement and distance will become same. So no, same thing is happening here. For a body moving in straight line without changing its direction, velocity of the body becomes equal to its speed. Okay, at that time, velocity and speed are equal. The slope of velocity time graph gives the acceleration of the body. See, in the first case, first we will discuss about the graph. In this case, slope of velocity. From that graph, what value we are getting? We are getting the value of acceleration. Displacement time graph. What value we are getting? We are getting the value of speed. Displacement time graph. What value we are getting? We are getting the value of course, velocity. The area under this graph gives the value of distance travel. That's a new thing, isn't it? The area of that graph. We need to find the area in that. Oh my God, it's a bit difficult, I think. Okay, let's do it. There are three types of velocity time graphs discussed here. Let's see what are they. So here we need to understand the acceleration, and the area of that slope will give what? The value of distance travel. So we will get distance from this graph. That means we have distance, we have displacement, we have velocity, we have acceleration, we have time. That means almost all terms we studied is there in this graph. So it is important. Let's see. If the body is moving in constant speed, the body is moving in constant speed means what? There is no change in acceleration. Understood? If there is any extra acceleration, if the body is moving in constant speed, at this point the body starts to move in 10 km per second and it doesn't change its speed or velocity. At that time, acceleration will happen? No. Acceleration will be 0. So, that particular map will be also parallel to the x-axis. See, constant speed. If the body moves with a constant speed, velocity divided by speed, then graph is velocity or speed, then the graph is straight line parallel to time axis, and the slope of the acceleration will be 0. Whenever the slope is 0, we can say that acceleration is also 0. Okay. It's a simple thing. Don't confuse by seeing this map. When a body is moving with constant speed, there is no acceleration. Understood? So normally if we find out the value of acceleration here, we will get what? We will get 0. when a body is moving with uniformly changing speed, if speed increases uniformly, the slope is known as positive slope, and slope gives uniform acceleration. Same thing. If this speed of the body is decreasing, so in this case, first case, the graph is going upside. See, at that time, what is happening? Speed is increasing, but uniformly. If it is not increasing uniformly, how will you get the graph? It will be a curve. Understood? Here also, it is decreasing uniformly. So, the graph is going downwards. Okay, let's see. When a body is moving with uniformly changing speed, if speed increases uniformly, the slope is known as positive slope of a plot, and slope gives uniform acceleration. The graph is straight line slows downwards, hence the slope is negative. Then the slope gives negative acceleration. And this term is something new for you, isn't it? Whenever acceleration is negative, it is called as retardation. Okay? Remember this term, it is very important. Okay? We never says that negative acceleration. At that time, we will say it as retardation. When the line of graph is going upside, it is uniform acceleration. When it is going downwards, it is retardation. Area in both cases, A and B, gives what? Distance travelled by the body. Okay, distance travelled by the body. For example, area, how to find out? We will take a small point from that in diagram I will explain, otherwise you won't understand. Next, uniformly changing speed. Almost this acceleration graph is also like what? That velocity graph. Let's see. If speed increases non-uniformly, the graph is a curve moving upward. The slope of tangent drawn at any point on the curve is positive and is equal to acceleration of the body. The graph is a curve moving downwards during decreasing, speed is decreasing and non-uniform motion. The curve moving downwards and the slope of tangent is negative and gives the value of retardation. So these two cases also we will discuss in that big board class when we are drawing this graph and all. So these are the three cases. Only remember those cases, and after that what we are going to find out these equations. So these are the equations. Okay, these are the equations. That much is there. In this see, regarding that maps, what we are getting, this one also we will just see. Acceleration time graph, two cases are there. Body is at rest. This will be a straight line which is parallel to the time axis or x-axis. Acceleration will be 0. We need to know that. Okay, when it is moves in uniform speed. No, when the body is at rest, when the body is moving in uniform speed, what will you say? It is same, isn't it? That's an interesting point, isn't it? When the body is at rest, acceleration is 0. When the body is moving in uniform speed, at that time also acceleration will be 0. This same graph we will get. Case 2, moving with uniform acceleration. So there will be different types of graph to be drawn from that. So these are the three equations we need to derive from these graphs. So let us see how we can derive those. This thing we will do it in board, otherwise you won't understand. So the first three equations of motion is very, very important. See, this one is V is what? V is the final velocity. U is what? U is the initial velocity. A is acceleration. T is time. S is distance travelled. Okay? These are the 5 terms we need to study, and these are the 5 equations you must know about this chapter. Okay, that we will detailedly discuss in the next class, and we will try to do a lots of numericals, problems regarding this. Till then, be safe my dear kids. Just go through that textbook notes and notes which I am giving in the in that group. So after that, if you have any doubts, you can mail me personally or you can call me. I will try to provide more study materials like this. Okay. Till then, be be at home, be safe, my dear kids. I hope all enjoyed these three classes because it's physics. Okay, it is physics. Yeah, I hope you all enjoyed a lot. Okay, my dear kids. So I am signing off from this part of the world. Goodbye, take care, and Jai Hind.